Well, we are about to come to an end of this lesson, and we're closing it by continuing talking about electroplating and see how it helps us to improve the appearances of certain metals. Let's look at it. Here, we're talking about making use of silver to electroplate something. This time, we're making use of the copper something to improve its appearance. The oxidation half reaction, in other words, what happens on the anode? Your anode, I said, must be of silver metal. You need to have that electrode of silver inside that solution. So if this is your silver solution, Ag plus inside there, here this one is your Ag. It's a piece of silver. Okay. That piece of silver, the atoms there are going to lose electrons to become Ag plus, and those electrons are going to go somewhere. All right, we'll see where they go. So that's your oxidation half reaction. Right, let's have a look at an electrolytic cell in operation. Now here is an electrolytic cell where silver is used to coat or to electroplate a copper key there. Now let's have a look at it. Here you've got silver metal. This is silver. This is a piece of silver. Okay. Inside the solution you've got silver ions, Ag pluses. This is Ag plus. This is Ag solid. Okay. This side oxidation is going to take place. So you're going to have Ag losing electrons to Ag plus an electron. That electron gets onto the circuit and moves in that direction. That is the electron I've shown there. It goes in that way. That side, remember we said the metal that is to be electroplated must always be the cathode there. Here is the key, the copper key that we want to improve its look. We want it to look silver. Okay, so now those electrons, when they get to this cathode here, which is the key, what happens? The Ag plus ions in solution receive the electrons and become silver, okay, become silver solid. Okay, now that silver solid is the thing that attaches itself around that key there, throughout the key, so that everything about the key begin to look silver. That layer of silver is there. So this is the reduction here. Reduction, this side, of course, oxidation. Now, as soon as this ion goes in there to become Ag solid, receiving an electron, an atom here of silver will lose an electron to become Ag plus. Hence, the solution, the concentration of the solution here remains constant. Sorry about that, but I think you can see that it remains constant. Okay. The reduction half reaction, what is happening, I've explained it, receiving of those electrons on the key as the cathode there to become silver. That is the layer that is forming around the key. All right. And continuing with application of electrolysis. Let's have a look at something else here. Extraction and purification of metals or minerals. This time here, we're looking at how aluminium is extracted. Okay? What happens? Molten oxide of aluminium, which is aluminium oxide, is reduced here to become aluminium at the end. Now, how does that happen? We've got a big pot. Imagine a big pot there with a carbon cathode at the bottom. So I will show you the diagram at the end. And this, on top of this carbon, on this big pot, we've got carbon anodes, okay, that are hanging in there, all right? And we'll explain what they do. The carbon anodes get oxidized so they can supply electrons. These electrons will be received by the aluminium ion, Al3+, which will then, on receiving that, will become aluminium solid. We'll show that as well. Let's move on.
So the aluminum ions are reduced to aluminium, okay, at the bottom of the pot, okay, all right. And then let's see. But what we know about this is that aluminium extraction is very costly. You're using that much energy to extract aluminium, so using a lot of electricity, okay, so you're needing much of that. If you're burning more coal, you need to burn more coal to produce electricity that is needed to do that work. When you do that, carbon dioxide is formed and it is pumped into the atmosphere, and thereby increasing the greenhouse effect, because carbon dioxide is a greenhouse gas. That leads to the increase in global warming, and increase in global warming leads to changes in the climate, so climatic changes, climate change, and that climate change leads to problems, floods, too much heat waves all over the place, okay, too much cold at times. So that is what global warming leads to. So that's our problem with the extraction of aluminium, because it needs a lot of energy. But nonetheless, let's close the lesson by looking at this diagram here. Here is your big pot. This is the carbon bottom that I was talking about here, minus there, which is your cathode, and then your positive anode carbon electrodes there, okay. These ones get oxidized and electrons get in there. The electrons come there, and then aluminium at the bottom here, aluminium 3+, gain those electrons and becomes aluminium, pure aluminium at the bottom, and you can take it out through that outlet. Okay, that's how electrolysis helps us in our industrial processes. Hope you enjoyed that lesson. It's my time to say goodbye. Keep well.